Hi, I'm Dave Kites again from the OTOW Woodshop. We're making a video to orient people on the sawstop table saw. We've had the saw for 2 years and we have had sessions and orientations, but we've never videoed one. So we get a lot more members coming in now, and so as a refresher or a reminder, we're going to make this video and put it on our website. There'll still be some orientation sessions, physical, face-to-face, on the saw. So why did we buy this saw? We had table saws. We had 2 big table saws, cabinet saws, good quality saws, Powermatic, but they didn't have guards, and they didn't have vacuum dust pickup around the blade. The fences were old and not very accurate anymore, and every time you closed it down, tighten it up, it would move 1/4 of an inch, 1/8 of an inch, one side or the other. They were getting worn out. Plus, this saw, of course, has the, now everybody knows, feature of it won't cut your fingers off. So we decided we would splurge and get one and see how it worked. And we're really glad we did. There were naysayers in the beginning. Oh, it's going to trip all the time, and we're going to go broke buying cartridges, and it's just not worth it, and all that kind of stuff. But we went ahead anyway, and we got one. And about 2 months after we had it in the shop, probably would have got my tires slit if I got rid of it. People really liked it, and so it's here to stay. We since have bought a second one. It's down the other end of the shop, and it is the identical, the professional cabinet saw, and it's an identical saw. It is just a year older than this one, or younger than this one, and it has a 36-inch fence system instead of a 52-inch fence system like this one, but otherwise the saw is identical. And they get a lot of use. Of course, table saws get a lot of use anyway, but these saws get a tremendous amount of use. So back to the reasons. The safety feature was one, the dust collection was one, the fence was one, changing the blade, ease of changing the blade. We didn't have a 2-wrench system on the saws that we had, so you had to wedge the blade and then use 1 wrench to get the nut loose and all that, as you may know. And that was just really awkward. So this has a two wrench system, show later on, to change the blade, and it's very easy to do. Now, the safety feature, to talk about that in more detail, it's electronic circuitry in the saw that senses, I think, the capacitance and whether or not there's any conductive path to the saw blade. So when it detects that there is, it activates a circuit that melts a little fuse, and then a spring is released, and the spring jams a aluminum cartridge, aluminum block, into the blade of the saw as it's spinning. And of course that tends to stop it pretty quick. And also they designed it so that the entire arbor drops below the table, down to where you see it now. So when it does get tripped, the saw stops in about 5 milliseconds, the rotation, and the arbor drops below the table very quickly. So it's going to be not making many teeth go past your finger, because it's stopping very quick, and it's also dropping away from your finger at the same time. The result is, as advertised, it usually, if you just bump it lightly, it probably isn't even going to break the skin. So it's a wonderful thing. The conductive materials that we have discovered over the last couple of years that cause it to trip, it will saw nails. A common misconception is that it'll, as soon as it touches a piece of metal, boom, it's down. That is not the case. If your hand is on the board and you got a nail in there in the board that you didn't know about, if your hand's close to the nail, there's enough conduction between the nail through the wood to your hand. It's a very sensitive system. There's enough there that it senses there's more here than just this little nail, and it fires. If you had only used push sticks and your hands weren't even on the board that you were pushing through and you hit a nail, it's probably not going to trip it. So that's that story. Now, other things that people have done is brought in sheeting, roof sheeting. They get it, well, I won't say, but they get it out of the dumpsters here for the new houses, and it's wonderful stuff. I mean, they got this particle board, it's free, and they're going to make something out of it. So they bring it in, and of course, with the foil backing on it, this instant that they start sawing, it trips the brake because the foil is very conductive, and they've got their hands on it. So we had made up a special sign, but we didn't put the foil board on there because we didn't know about that until, I don't know, a few months ago, several months ago now. But treated wood, the new chemical in treated wood is more conductive, seems to trip the saw easier than the old chemicals used to. And wet wood, very wet wood. It has to be really wet. It's got to be so wet that when you're sawing it, it's kind of spritzling in your face. But really wet wood will also trip the saw. Again, depends some on where your hands are, if you're touching the wet wood or not. But if you get enough conductivity going there, it's going to trip the brake and it's going to fire. Now, our policy here in the show, well, I should say more about that. The brake is active, armed, ready to fire whenever the blade is spinning. Whether it's spinning under power or you've turned the saw off and it's coasting down. In that time, the little green light on the switch still blinks green, and it is armed. And if you bump the blade when it's coasting down and you bump it with something conductive, it's going to activate the brake. Even though it's not under power, it's going to activate the brake. So you want to be aware of that. The safest thing to do is to be sure it's stopped. And if it looks stopped, if you just take the extra second and glance it down here to see if the green light is on steady, if it's on steady, it's safe. If you glance too quick and it happened to be blinking still from the coasting, you see it blinks green while it's coasting down. And if you just glance and it's blinked and you think it was on steady and you touch it, boom. But the light goes solid the very instant that the blade actually stops. I mean, it's a very small fraction of a second, so that's not going to happen. So see that it's stopped before you touch it, and if you want to be really sure, look down there and make sure that light is steady green, and then it won't trip when you touch it. If it does activate, it, of course, destroys the cartridge. They're one-shot cartridges. And in jamming that aluminum into the blade, we use all carbide tip blades. It may break off one or two teeth of the blade when it does that. And the shop policy here is that if you trip the saw, well, I don't think of any cases where it's been tripped that have not been diagnosed to be preventable, and therefore the member had to compensate the shop for the cost of replacing the cartridge, and if the blade was damaged, the cost of replacing the blade. Cartridges now are around $100. They seem to go up and down a little bit, and the blades we use are $40. So it's not cheap to trip the saw because you have to compensate the shop. So you're going to be careful about it. We've had several people always ask, how many times has it been tripped? And I don't have an official count, but in the 2 years on this saw, I think probably 8 or 10, maybe a few more times, maybe 10 or 12 times, about that many times. Which, for the use in this shop, it's used every day. Sometimes not on Christmas Day, but most every other day. And it gets a lot of use, so it's not a very high percentage. But it has been tripped several times. Metal embedded in the wood, of course, is never a good idea to run through your table saw, even if you got carbide blades. Yeah, it doesn't really hurt them, but it does tend to dull them a little bit, so you don't want to make a habit of it. So that's about it for the safety feature. It is very effective. I've tripped it myself. I bumped them. Well, I'll tell you the details. But anyway, in my case, it just happened to touch my fingernail. Just touched the top edge of the blade for an instant. And it only took just a teeny little chip out of my nail, but it fired the brake. So it's very sensitive. Now let's talk more about the saw parts itself. This guard assembly, so I'm going to elevate the blade so you can see it better. So now this guard assembly has really got multiple purposes. Of course, first it's a guard, and there are two parts here that we have not, no longer have in our setup here at the shop. The design of this has another piece in here that's pivoted up at this end, and one on each side, and it goes up and down like this to cover up this opening here. When you have your wood coming through and it's lifting up the guard like this, okay? The reason we have removed those, well, we didn't remove them, they got removed. What happened was they are loose on the back end, so they can go in and out. And people would grab this here to put this down after they did their setup. They'd grab it here to put it down, and they'd squeeze those two together. And when they held them together and they brought it down on top of the blade, those pieces underneath here where they could not see very well, those pieces were across the blade, like so. But they didn't know it. So then they got all ready and they turned on the saw. Well, the pieces, of course, were instantly shredded. That happened, so we replaced them, and again, and again, and then we said, we're not replacing it anymore. So, if you're using this saw, one of the things that we talk about in the saw use demos is don't try to remove the little cutoff pieces that are over here by the blade. You will inevitably end up bumping the side of the blade. It may not cut you, but it will activate the brake. So leave those little cutoffs sit down there, and after the saw is off, you can clean things up. Back to the function of these things. So we have this guard. It is also a dust pickup. Inside of it, there's a channel. This fan action of the saw blade in this lower part blows the sawdust that happens to come up around the blade, blows the sawdust around here. There's another channel here, and it comes here, and it goes through here and out this pipe. There's a plug in here right now. You can see that somebody was ripping something and made some shredded stuff, and it didn't make it through here. It's very unusual, but it happens. So this is now plugged, so we're not getting any benefit from this guy at all. In a little while, I'll show you how we simply clean that out. But if you were going to use the saw, you should always look here and make sure this is open so that you're getting the maximum dust collection out of the thing. So it's a dust collector, it's a guard, and it has on it anti-kickback pawls. The big one, and they can be optionally stored away like that or dropped down to be used. And then there's these two little pawls, one on each side, that are permanently here, and you cannot put them out of the way, except if you raise the blade higher than you really should, your wood will be down below the pawl and it will be inactive, okay? But if you put your blade at a normal height above the wood, this pawl is going to engage your stock. It's going to engage whatever's on this side and this one that's on this side. Okay, so we have these pawls. You have the riving knife. The riving knife goes up and down with the blade, so this gap between here always stays the same and small. And of course, the riving knife is there so that when you're cutting wood, it can't drift back over this way and get caught on the back side of the blade here, which is coming this way, because if it does come over there and catch this, it flips it up in your face. And you may not be so lucky as it to go that way, it's going to come up and hit you. So we always use the riving knife here. I'll talk about another option on this riving knife in a little bit. So the riving knife, the vacuum pickup, the guard, the pawls, all benefit of having this thing in place. So when you use the saw, you should leave it in place. Used to be, the first thing that happened when a fellow bought a new table saw was he took the guard off, put it on the shelf, and it stayed there and collected dust until the guy was done with using the saw and closed up his shop. This one, not the case. It's here. It does get used almost all the time. There are a few operations you can't really do this with, but most of the time it's in place here and it is being used. So then there's the fence. The fence is a very sturdy fence. It locks down very securely when properly adjusted. It doesn't move but just a little bit sideways, and that depends more on how you moved it than anything else. If I push it on one end or the other, there is a little play in it. It has to be loose enough to move, of course. So if I do this and then I clamp it down, I'm going to get a little wiggle one way or the other. If I put this tightening handle down part way and move it, it moves only just a little bit. It's all adjustable, but we ask members not to adjust it because it can be misadjusted and then it causes damage. We had it adjusted by someone who didn't quite understand what they were doing, and they lowered it down so far that these indicators for the measuring rule here dropped down onto the rule. And before I happened to notice, or anybody else happened to notice that knew that it wasn't right, they'd worn away the rule. So I had to replace the rule. So don't adjust this. You can get it, it'll adjust this way, it'll adjust this way, it'll adjust tightness here, a lot of adjustments. Please don't do them. If you find it's out of whack, do like we ask you to do with the rest of badly adjusted stuff in the shop. Put it on the whiteboard and we'll tend to it. Okay. But it's a very good fence, and the accuracy, we've set it up very carefully, and as long as nobody fools with these indicators here and changes them, it's very accurate and you can trust it. What I always tell people to do is, come in, you're going to use this, you got a lot of cuts to make, you want to use the rule, take your tape or your ruler, whatever you want to use, set this on something like 10 inches, and then measure and make sure it's 10 inches. And if it's a 16th off, then I guess you can move the indicator. So check it before you use it, but once you get it right, it's very repeatable. Okay. All right, so now we're going to talk about the blade and removing the riving knife and that stuff. So the throat plate, to start with, comes out simply like that. And underneath are the buttons. This little button has an underneath side and an underneath side here, and they slip underneath these. This one, and there's one over here you probably can't see. But so when you put this back, that's what holds this down on that end. So when you put it back, if I put it back like this, I didn't do good. You see, it's not down. Okay. I have to slide the buttons under the other buttons like that. Just that little bit of difference makes all the difference in the world. Now it's down. Okay, so that's what you have to remember when you put that in. If you don't, when you cut your wood, it'll go up there and drop off. Okay. So now, there's a handle down here. This gray handle is what's holding the riving knife and this whole assembly in place under here. So we're going to, it's removable like this. You just lift that handle all the way up, and this thing opens up and out it comes. When it goes in, it has this round thing goes over a big thing that you really can't see, but a big piece of rod that's down in there that centers it up. And these 4 holes get pins through them when you close this handle down, and it squeezes this together. And that's what holds it in place. Okay. Now the cartridge, the brake cartridge, is right here. You can see the silver of the top labeling of it right here. It's held in place by a pin that has a red handle on it. It's way down here. You may not be able to see it, but it's down there. I've got this up as high as it'll go. The red handle down here. The red handle, when it's locked in place, the cartridge, is at this angle. To get the cartridge out, you lift that red handle up about 90 degrees, so now it's 45 degrees up instead of 45 degrees down. And when you do that, you can wiggle it and it will come out sideways. So it's in there like this. You reach in there, you turn it up like this, and then you wiggle it and it comes out this way. Okay? So now the cartridge is no longer held in place. It's just sitting in there. And you can reach in here, and they put a finger hole on the top part of the cartridge. And you can get in here and you wiggle it a little bit and it comes out like so. Okay? You can see on the cartridge where the electronics plug in. Inside here is that powerful spring that pushes this up. When it's in there, it's like this. This comes up and hits the blade. The blade is running less than 1/8 of an inch away from this when it's in position. So it doesn't have far to go. The big spring really jams this thing up in there quick, and it stops the blade. This is held in place in there by a big pin through here, which is right under this handle, and a smaller pin that is fixed down here, which is way down at the bottom there. And this hole is where this guy goes when you put him in, okay? So that's the cartridge. That's for the 10-inch saw. The dado one, we'll talk about again in a little while, is different. And if you're going to do dados on here, you have to change the cartridge in addition to putting the dado blade on. Because the dado that runs on these saws is 8-inch diameter. No other diameter, 8 inches, because that matches the cartridge. The blades you run on this saw are 10 inches, no other diameter, because that matches this 10-inch cartridge. So now we're going to put the cartridge back. We're going to put the big pin and the little pin in at the same time. Start with the big pin. It's right under this handle. You can get it just started on there, and then down at the bottom, you can reach down at the bottom and feel where the little pin is and put that into the little hole, and then you slide it and it goes over and it's on. Then you got to put the locking pin in. Start with it up. We're going to put it in like this, and then we're going to turn it down, okay? So we start with it up. And then we put it in and we turn it down. It's locked in. So the cartridge is back in. The dado cartridge goes in exactly the same way. It's just a different size. Same pin holds it. Same 2 mounting pins hold it. It goes in the same. It's just a different size. So that's the cartridge. The gap between the cartridge and the blade right down here is about 1/8 of an inch. And we have a gauge that I didn't get out before I started making this video, but we have a gauge that you can check this gap with. That's important because if you bring your own blade to the shop, you can run it on here if it's a 10-inch blade. And when you change it, if you've got an odd and some old blade you got somewhere years ago or something, I don't know, anyway, you got this blade that's a little bit oversized, it may be too close to this cartridge, and you don't want to have this vibrate a little bit and hit this cartridge when you start the blade up. And I know that sounds funny, but it happened once to a fella. He had a blade. He put it on there. It was oversized. He said later, yeah, when I put it on, it was really close to the cartridge. I probably couldn't even got a piece of paper in between the blade and the cartridge. Well, that wasn't a good idea. You should check it with the gauge and make sure there's almost 1/8 of an inch gap here before you think you're okay. So that's the story on that and the gap. The gap's adjustable by this yellow thing over here, again, we ask the members not to adjust the gap. Just leave it. As long as you're using shop-provided 10-inch blades or 99.9% of other 10-inch blades, it's fine the way it is. The gap is correct. If the gap is too big, the saw knows that from the electronics and it will not run. So if you've got an old blade that's been ground down a lot, of course probably the tooth shape isn't right anymore anyways, but if it's been ground too much, the gap will be too big, the saw will know that, he won't run, he'll blink some lights for you on the switch, but he won't start. And that's something to keep in mind if you've brought in one of your old blades and you're trying to run it. So that's the story then. I'm pretty much on the whole cartridge. Yeah. Now let's talk about changing the blade while we're here. It's a 2-wrench system. The wrenches are on the below the table on the side of the cabinet on your left as you're facing the saw. Open end, box end. Open end goes on the left on the arbor. There's a machine flats there for that. The box on the nut. It's a right-hand thread. So it's just like you would think it would be. And you're going to pull it. So some gorilla put this thing on. Okay, I'll get it. I'm going to hurt myself. I'll put this like this. I'm going to put the box on over here. I'm resting this wrench against the side of the opening here. And then I can pull this one and get that off. Loosened it. Take the nut off. Now, if you drop the nut down in the hole in the bottom of the saw, you can get it out. There is a door on the left side of the saw that when you open that big plastic door, which covers up the motor, but anyway, you open that big door, you got a hole big enough you can look in there, find it, reach in, get it out, no problem. And the washer or the stabilizer, whatever you want to call it. And then the blade comes off. Very simple. This is one of our fine tooth blades, 60 tooth, finer tooth. Okay. While I have this out, I'm going to show you here this plenum. This opening here around the blade collects the dust. It's hooked to a 4-inch hose, and that 4-inch flex hose goes out to a fitting on the back side of the saw that's fixed and 4 inches, and that's where you hook your vacuum system to, and that's what we've done. We're not going to talk much detail about the vacuum system. I'll tell you why in a little later. But that's worth pointing out while we're there. So that's the inside of the saw here. We've looked at the cartridge and the way you get out the riving knife, and we've taken the blade off and showed you the plenum in here. Now we'll put the blade back. So the blade goes back in with the teeth facing you, pointing at you when they're spinning around, so that they hold the wood, you know, they're hitting the wood downward when it's entering on this side, obviously. And we put the nut back on. Now, when you tighten this back up, the motion of the blade tends to tighten the nut anyway, so you don't have to make it really tight like the fella before me did. All you got to do is get it like this, and I'm pulling with this one, pushing with this one, and just that much. That's tight enough. That will not come off. Put the wrenches back and put your riving knife and dust collector and anti-kickback pawls and all that stuff in here. Push this handle down all the way till it stops. It gets down to an angle about like this when it stops. And put your, see that we're flush and we're back in business. All right, a couple more things. Now, we've talked about this a little bit ago. If I'm trying to cut slots in a board underneath, I can't do it on this with this in place. You see, my board comes across like this, and if it's like what's left is what is my hand, okay? And in other words, the slot's underneath here, but it comes up to here and then it stops, and this much more is still wood, solid. I'm going to run into the riving knife. It won't go, no matter what I do, because it goes up and down with the blade. So what in the world do we do that? I want to cut slots. Well, we have a way to do that. We take this out. We remove this riving knife. And over on the tool board to the right of the saw, hanging on a nail, you'll find this guy. And this is a riving knife. You can put him in there and tighten the handle down, just like you did with the other one. Now, he's lower than the top of the blade, so I don't have to cut all the way through the wood. So the wood will pass right over him, and I can cut my slots. And that's what he's for. No dust pickup, no guard, no pawls, just anti-kickback protection. Your wood can't drift over this way and get into the blade and get thrown back at you. That's why you still want to use him. So put him in if you're cutting slots to prevent the kickback. Okay? Dados. Mentioned it a little bit ago, but now I'll show you. Down at the other end by the number 2 saw stop, by the other saw stop, on the shelves behind it, behind the drill presses, you'll find on the shelf this guy. It says Dado, and he's a different shape. You see, he's bigger this way, so he takes up that distance between the 8-inch Dado and the 10-inch blade. But he mounts the same way. Big hole, little hole, locking pin, all the same. But this is what you put in if you're going to do dados. In addition, there's the dado throat plate down there, right next to the cartridge. So you want to put this in when you're going to do dados. And it looks like the widest dado that's been done so far is 3/4 of an inch, and that's the way this was built. Yeah. That's the way. No, it wasn't. It was built narrower. It's been worked on a couple times here, but that's okay. It's made to do that. It goes in the same way. The little buttons go under, and so on. But I can't do it, of course, with this guy in the way. So when you dado, you don't have a riving knife. I guess you noticed that. So let's talk now for a second or two about blades. We have in the shop these fine tooth blades, 60 teeth per inch, and we have, we have the combo blades, 50 teeth per inch, with a different kind of tooth arrangement. There's four cutting teeth, and the 5th cutting tooth, and then a cleaner, and then a big gap, and then it repeats that pattern. Okay, that's a combo blade. It's good for ripping, light ripping, and cross-cutting. It does a good job on both, unless they're on the extreme ends of sizes. Okay, so it won't rip. You wouldn't leave this in and rip 2x4s. You really ought to put the rip blade in, which I don't have one handy here, but it's a 24 tooth with great big teeth on it and great big spaces between the teeth. That's so the shreds can get out. So that's why you want to use the ripping blade if you're going to do a lot of ripping. This will do for some 1x stuff that you're going to rip, but if it's 2x stock, you probably want to put the rip blade in. Okay, so we have those blades available. We try to keep them sharp. If they're not sharp, put it on the whiteboard, let us know. We got some we can put out, and then we get them resharpened. We have them resharpened a few times, and then we buy new ones. So that's it for those accessories. And I think that's all we need to say here. All right, so now we're going to talk finally about the elevation changes the height of the blade. And over here in this one is the bevel. They both have a black knob in the middle of the wheel. That's the locking device. So when you want to change the height of the blade, the first thing that you should touch is not this handle. It's this black knob, because you want to know that the brake has not been left applied by somebody else. And if you grab this and you start turning it and it's hard to turn, it's because it's probably locked, okay? So you just take this a twist or two to the left and it backs out and it's not locked anymore. And when it's not locked, it turns very easily, okay? When it's locked, and that's all it takes to lock it, it doesn't like to turn at all. And if you force it, you're going to ruin the lock. And that happened on our old saws, but fortunately, so far, people have listened and paid attention, and when it starts to turn hard, they stop and check and say, oh yeah, I forgot to take the lock off. And they haven't ruined the lock, so it still works. Same thing on the bevel. Unlock it first. This one, we asked that you normally leave it locked. So when you have beveled and now you put it back straight up and down, like you're supposed to before you leave, you put it straight up and down, snug up the lock. Leave that one locked. We just don't want any chance of vibration, putting it a little bit out of line and then somebody not noticing and cutting a bunch of wood and finding it's all at a 1.5 degree bevel angle. So, and that happened once. It was very bad. Fella lost a lot of good wood. Anyway, so please lock that one. This one we don't care, because you're going to check this first whenever you change the elevation anyway, right? So even if it's locked, you'll discover that. And if it's not locked, you'll discover that, but it won't matter. You'll correct it to the right condition, which is unlocked, and then you'll turn the wheel. So you can turn the wheel. When you turn the wheel, you can raise the blade all the way up on this machine. A 10-inch blade stands 3 1/8 inches above the table when it's all the way up. That's the most you can cut in one pass on this saw. The bevel, because you got your indicator here, it's accurate, but not very precise, because you can't really read it in between these big marks very well. So if you want to do some precise work at an angle, you'll have to use some kind of gauge or template or measuring device up here on the blade to make sure you have the right angle between the table surface and the blade. If you count on this alone, you'll be close, but you're probably not going to make segmented work out of it that way.
That's weird.
Yes. In addition, when you get done beveling, up on the saw, on the fence, you'll find this little square. It's a magnetic square, and you can use this to check that you've got it all the way back up straight against the stop. Now the stops in here, stop in here at 0 and 45 are set quite precisely. When you get to this, when you're approaching the stop, getting close to being straight up and down, slow down your cranking and gradually come up to the stop, and then just snug it against the stop, and it should be pretty straight. And you can check it with this guy that lives up here on top of the fence. Once it is straight up and down, lock it. Okay. This saw has the feature of not having to change the throat plate when you bevel the blade. The mechanism inside is designed and built so that the arbor actually travels a little bit laterally at the same time that the blade is tilting. The combination movement makes the blade go through the slot in the throat plate in this kind of a motion. Instead of just sitting there and trying to pivot, it moves like so. And so the slot can be quite a bit narrower than a normal saw. In a normal saw, if you're going to bevel, you have to take the throat plate out, or at least you have one with a big wide slot in it in order to let the blade tilt. This one will go to 45 with the normal throat plate in there. So you can remember that. You won't have to worry about that. Okay, so that's it for the ups and the downs. When you finish with the saw, put the blade below the table and straight up and down, locked. And this one, I don't care. Locked, we don't care. Locked or not locked, doesn't matter. So that's it for those adjustments. This is the switch. Finally, we're going to talk about running the saw. There are two switches here. This one here is the power switch. This one here is the blade paddle. It's a switch. Flip that up. We get a green light and a blinking red light. It is booting. There's a little computer in this saw. That's how he knows whether the gap is correct, whether there's anything been left in the saw from maintenance or something that's up against the blade or whatever else. So he checks some stuff. Now he's happy and he gives us a solid green light. That is our indicator that we can use the saw. All right. When the blade's not spinning, the green light's on steady, you can touch the blade, it will not activate the brake. To make the blade run, you pull this paddle out. And when you pull the paddle out, it'll start. So, it blinked as it was coasting to a stop. Almost exactly the same time that it stopped, the blade stopped, this stopped blinking. So now we know that we're safe again and I could touch the blade again, not a problem. But I could not touch it safely if this was blinking. Okay? When you're using the saw, if you forget and you have it running and you turn it off with the power switch, it'll turn the saw off. But let's see what happens. If you notice at the end of that, there was a brief red flash. And then both lights went out. Because he's out of power. Okay? He was running off capacitors to do that other stuff until he went out. So now he's out. So now I'm done. And I come back and I say, I'm ready to cut. Oh dear. It's not going to work. He knows that this switch is in the wrong position for the situation. If I simply push this in to the off position, he gets happy. And now if I pull this out, he will run. So that's a common mistake, to do that instead of push this in when you're done cutting. And what happens is when you come back like this, instead of getting this situation, you get the blinking red and green lights. Now you notice when I turned it off just less than a minute ago, and then when I turned it back on, I didn't get the blinking red. He didn't need to reboot. He's smart enough to say there's no way they could have opened this up, done something inside there, and messed it up. It just wasn't enough time. So he doesn't go through the complete reboot. He just says, okay, I'm ready to run. So now he's ready to run again. So that's the simplicity of it. Power is on. When you're done using the saw, for the afternoon. If somebody's not standing waiting to use the saw, which would be pretty rare, but if they were, you could just let them use it. Otherwise, turn the power off when you leave. We don't need to keep the circuitry energized for hours and hours and overnight for no reason. So we turn the power off. Okay. Now, when I did that, you probably heard the vacuum start. And you probably heard that after I pushed this in and shut the blade off, the vacuum kept running for a while. That's because we have an automatic on-off system installed for our vacuum. It's an IVAC system, commercially available, a little bit pricey, but it works real well. It senses when power is flowing through the machine's cord, in this case our sawstop, and it senses that, oh, he's running the machine, he's drawing power, I'm going to activate my switch. So he turns on a switch, and in that switch, what we have plugged in there is the vacuum. So he senses power through the cord to the saw, turns the switch, turns the vacuum on, vacuum runs. The IVAC system then can be set, and we set ours for about 15 or 20 seconds, to run that long after the blade is off. After the power in the cord to the saw goes away, and we know he's off, it still runs for 15 or 20 seconds to clean out the pipes, the hose, whatever. So then it stops, and then he's ready to run again when he senses power again. So that's how that all works. I haven't talked much about the sawdust system because we have other videos about the sawdust system on both saws. And I encourage you to go and look at those. They're on the OTOW Woodshop website under the Education tab, and they're very comprehensive. They show you all about the different parts of the dust collection system, and how to clean it out if it gets plugged, how to tell when it does get plugged. It tells you all that stuff. Just as an example of a simple thing to do, we're going to clean that out, show you how simple it is. The problem here is that the saw is going to blow the sawdust here. It's going to go up in this channel inside here, go around. It's going to try to, but this vacuum from this hose is pulling in this channel up here, and it's plugged with sawdust. So he's not going to do that. And all this sawdust that comes up here is going to come out on the table all over the place. Okay, so we don't want to do it. So we want to unplug that. When I take this off and I look in here, there's sawdust in there too. Shouldn't be any there. This hose goes around and hooks into the big pipe under the saw, under the table, where our vacuum hose is hooked to. There's a T down there, and this guy hooks into the bowl of the T, the side of the T, to pull a vacuum on this part of the hose. And then it pulls through here, and it through here, and through here, and it's supposed to get there, but it can't get there. Okay. Sometimes this will come loose by knocking on it, and sometimes it won't. So what we can do then is we get a shop vac, like the one that's right handy here underneath our saw, and I'll clean that up. Well, it doesn't want to come. Let's see what happens. Oh, I can get in there with a straight, small stick if this is down. You can't do it if this is up. But if this is down, you can get in there with a straight, small stick. And now, thank you, Ben. There's the culprit right there. Nope. Well, there's a curlicue in there we just can't get out. What we'll have to do is unscrew this, open this up, and then get it out. So we'll do that, but normally you wouldn't have to do that. It's very unusual. See that big long squiggle he got in there? I don't know exactly how he cut that, but he did. Well, before I do that, I guess I gotta just do something like, say. So we got a little more work to do here, and I'll take this open and get it out. It doesn't normally happen that way. You shouldn't have to fool with that kind of thing. But just as an example how it was to use a stick to poke in there, it usually gets it all out pretty easy. And you just vacuum here and it sucks it right out. So that's about it for the orientation of the sawstop. I hope you'll get something out of this, and if you, you know, have the physical orientation here face to face, and then later you don't remember something exactly, we'll have this video on the website for you.